Good morning and good afternoon. Welcome to this month's FDTD Satellite Applications webinar on using Mimic Total Precipitable Water for winter applications. We're very happy today to have Dave Zaff from the National Weather Service in Buffalo talking about, surprise, snow in Buffalo, but not crippling snow. Let's go to the next slide, please. This is a series of peer-to-peer training. The satellite chat library is available online at the link here. We are always looking for speakers. If you have someone in your office or you yourself have found a satellite application that's been very useful for a particular event, please let us know. We can help you develop a presentation to share with your National Weather Service colleagues. Next slide, please. Just some protocol. I guess the big thing is don't press hold, but Dave will talk 15 or 20 minutes. You can send questions via GoToChat or ask them during the Q&A following. Thank you for joining us on a high-risk day. I know the weather today is very distracting, but take it away, Dave, and thank you. Dave, you're muted.
Hello, hello. Can you hear me now? Can you hear me now?
Yes, I hear you, Dave.
Yes, I can hear you.
Okay. So yeah, thank you both Dan and Scott for allowing me to do a short presentation today. With the severe weather down in the south, I will make it even shorter than the 15 minutes, I think. The Buffalo area indeed is known for its big snow events, in particular lake effect snow. So just a fun shot. This is your classic backyard furniture picture taken a few days before the events that I'm going to talk about. This was an event here that we had as much as 2 to 3 feet of snow in some locations. And you can see just by the sharp gradient, in this case, Buffalo had virtually none. So, but I'm not going to talk about these big events. That's the interesting part about this presentation. I'm going to talk about the little stuff, just the 1 to 4 type accumulations. In this case, a few days later. So this slide here, first I just want to draw your attention to the focus area. This is the Buffalo area of interest, or the area of interest, including the Buffalo city. The image on the upper left is the HREF 24-hour ensemble max, kind of like the worst case scenario for a forecast. In this case, you can see by the color curve, there's about 2 to 4 inches forecast. Again, from the CAM's output, sort of the worst case scenario. Our forecast for this particular event was on the order of 1 inch or less for the Buffalo metro area. There's an area over to the south of Buffalo that has some higher terrain, and you can see there's higher snow amounts there. The table on the upper right is just kind of a summary of what I mentioned. HREF ensemble max of 2 to 4. We were a little bit less than that, which is pretty typical. You don't always go with the worst case scenario. And the result is in with Kokora's reports here, assuming you can see some of the numbers, anywhere from 1 to as much as 5 inches across the Buffalo metro area. So in summary, with this particular case, just from looking at a quick CAM's output, one slide, not showing any of the synoptic detail, modeling did an okay job. We ended up under forecasting the event by a little bit. And just to emphasize, This was not a lake effect event. It was primarily synoptic in nature. Now, 1 to 4 inches isn't a big deal, but it caused a number of problems. This next slide shows just a smattering of accidents that occurred. Again, 1 to 4 inches shouldn't be a big deal, and we like to joke that we can, we don't blink an eye to that type of a snow event, but it did have an impact, particularly for the morning commute. So what I'd like to do is take a look at this from an observational standpoint rather than focusing on a lot of model data. So this is the channel 9 or so-called mid-level water vapor image from 0Z on the 21st of February and then going through 8Z on the 22nd. And I stopped it at 8Z for a particular reason. This is for Eastern time zones, this would be about 3 a.m. And this would be the point where we'd be making sort of a go, no-go decision on any type of changes to the evening forecast package. So the midnight forecaster would be on duty, and they would be making some changes if necessary to the existing forecast, deciding whether or not we should go with an advisory or whatnot. So in this pretty typical synoptic pattern here, you can see the subtropical jet coming up across the area, weak baroclinic leaf. You can see the cold core developing, a nice comma shape to it. You can envision a surface low probably developing somewhere over the western Ohio Valley area or toward Michigan. And, it doesn't look all that unusual for a winter event. But what's interesting is your eyes are drawn to the synoptic feature itself, but the moisture is actually coming from a different location. So what I'm going to do now is show this thing called MIMIC, which I'll explain in a minute. This thing called MIMIC is basically it's total precipitable water. And as you're looking at this 1 hour time step, time matched here between the water vapor GOES 16 satellite image and the precipitable water, you can see the moisture is actually coming from the Gulf of Mexico. So I found that kind of interesting. There's a notable difference of what we typically call water vapor, which is really an infrared image, and where the actual water vapor is coming from. So what is MIMIC? MIMIC is the morphed integrated microwave imagery at SIMS, and then they attach on TPW for total precipitable water. This is a really interesting product. I learned quite a bit about it over the past month, just passing some emails and discussions between Scott Lindstrom and I. So what MIMIC has been around for a number of years, at least a decade, I think, and it starts with a bunch of polar orbiter satellites, 6 or 7. Let's call it 6, just to for an example purpose. So you have, let's say there's 6 polar orbiters going around twice a day. That gives you 12 images. That's not going to give you an hourly time step. So what they're doing out in SIMS is they're taking this data, then matching it with the GFS winds, going backwards in time and forwards in time to advect the precipitable water that are available through these various swaths. And from that, you can get an hourly precipitable water loop, which I think is fantastic. And I put in parentheses, and I really should probably make it italicized and boldface. Who wouldn't want an hourly precipitable water image or loop? This is fantastic. And as advertised for a number of years, MIMIC is very useful for tropical systems, atmospheric rivers. There's a beautiful atmospheric river today. After this meeting, take a look at the one going right up the middle of the Atlantic toward Greenland. Just phenomenal. But why would you look at an atmospheric river in the wintertime in forecasting winter events? So for this next slide, I'm again looping the same image that I had before, except for it's a smaller loop. It goes from 23Z to 8Z on the 22nd. Again, stopping in the middle of the mid-shift for Eastern region. In this case, what you can see here, and I'll kind of move it around with the mouse and then I'll put some arrows on, you can see there's actually not one source of moisture, but 2 sources. One is a source of moisture coming right up the Gulf, as I mentioned before. And then there's another surge of moisture coming from the Caribbean. They're merging over the Mississippi Valley, going up the Appalachians. And by 8Z, the tip of this is pointing over the Ohio Valley, poised to be right over us several hours later. So if we were looking at this, again, from a forecast standpoint, you've got all the model data in. You're trying to make a decision on if you should be making any changes to the forecast process. This would be an instance where all other things being equal, if you're just thinking snow, this might be a scenario where you might want to go with a higher end guidance, knowing that you have all this moisture pointing right at you. For the next slide, I just drew some straight arrows. They're not perfect, but the idea is to represent the idea of this merging of two different plumes going over toward the Ohio Valley. Here's another loop. This one extends through 13Z, or right across our commuting hour, across the Buffalo metro area. And at this point, you can see that plume is almost right overhead. The color curve here doesn't quite capture, the potential impact, because it's really designed for summertime convection and atmospheric rivers and such. So this would be one of these things where if I had it in AWIPS, I'd probably modify the color curve for winter to try and pull out the detail a little bit. But you can see that tip of the atmospheric river is indeed going right over the Buffalo metro area, and it matches the MRMS radar image that you see here, with the most of the moisture right over the area, matching that water vapor image that we had before with a warm conveyor belt moving over. Your cold air, or your coldest air mass is probably over Michigan here, and then there's a surface map showing, again, that synoptic nature of this system. Just to emphasize that the models have this data, there's no reason why we shouldn't use it. This is a HREF 12-hour forecast showing the same plume over the area. We just don't use it very much in the wintertime. I think precipitable water is something that we're just accustomed to looking at in the summertime and not in the winter. So it's not like it's not in the models, it's there, but now we have this observational data set to complement that. This next slide shows a series of SKU-T plots, one from 0Z before the event, one from 12Z right in the middle of the event as that atmospheric river is pointed right at Buffalo, almost right overhead, a fairly classic synoptic sounding here. And then 12 hours later, as your moisture aloft starts to be taken away, and we're left with just low-level moisture. The numbers here, 1, 2, and 3, match the numbers down here. What you can see is before the event, we were fairly dry, relatively speaking, from a climatology standpoint, and we spiked way up above normal climatology and then dropped back down after the event was over. So it matches what the MIMIC data was showing us. Now this slide here is a repeat, and I had to do that because I want to show you what happens for the next 24-hour forecast. So this is exactly what we showed before. We had 2 to 4 in the forecast from a model standpoint. Worst case scenario, we had a trace of snow in the forecast, and we ended up with more than we expected. Now what I'm going to do is I'm going to go to the next slide, and I'm going to show you the exact same information, just with a 24-hour forecast, or moving forward 24 hours. So here is the next forecast, again using the exact same data set that I had before, HREF, sort of the worst case scenario, 2 to 4, maybe 4 to 8 over the higher terrain. Down on the lower left, you can see the Buffalo forecast forecasting 1 to 2, maybe 2 to 3, depending on where you are. Same information I had before, sort of the worst case scenario, HREF 2 to 4 or 48 if you're in the higher terrain. Buffalo was forecasting 1 to 3. And then from the COCORA's reports that came out later, you can see it was a pretty good forecast. So in this case, we might have undercut HREF a little bit on the ensemble max, which is typical. But overall, it was a fairly good forecast, both from a modeling standpoint and from the forecast standpoint. There really wasn't any big surprises with this event. This event, by the way, was also primarily synoptic. There really wasn't much lake effect with it. Now let's take a look and see what it looked like from the satellite. So this is a day-and-a-half loop at hourly increments. And I've got both events covered here. So you can see the first one with the synoptic feature moving right overhead. The cold pool moves by a little bit later. And then you can see, there goes our first system, if you can follow my mouse. And then the second system comes in from Canada and moves southeast across the Great Lakes, upper Great Lakes, and into the Buffalo area towards the end of this particular loop. So there is a notable difference between these two synoptic features. One has this subtropical jet, and the other is clearly coming from, basically it's a clipper coming from Canada. Now comparing this with the two events from a mimic TPW perspective, you can see that first one with that nice plume of moisture coming up the Appalachians and then moving off the East Coast. And the second one really doesn't show up very well at all. And that's exactly what I wanted to show you. It's a much drier system overall. There isn't that plume of moisture. It's basically Canadian sourced or a polar continental air mass moving over the area. And so you could use this, again, just like you did for the other one, to decide whether or not the models were overdoing or underdoing any type of forecast snow amounts. And of course, all the other caveats that are in there with all the three-letter acronyms, QPF, SLR, DGZ, excuse me, and everything else in between. You put all those things together to produce your forecast. But in this comparing those two events 24 hours apart, you can see there's a notable difference in the amount of water vapor moving toward and through the Buffalo metro area. So just to show the difference, I've put another set of soundings up here 12 hours before the event on the 23rd, 0Z, 24th at 12Z. Yep, and then following 12 hours later. So what you see here is a much more muted response from any type of surges of precipitable water moisture. You don't have this spike like we did for the event that was 24 hours prior. So as a summary, I think this Mimic product really has a lot of potential, not just for summer applications, but it could be useful for the winter as well. So I think we can use it or look at precipitable water in general. The Mimic product has the fact that we have hourly access. That's fantastic. And I do have to have that caveat in there. Every situation, of course, is unique. But identifying these atmospheric rivers when they're overhead in the snow scenario, we might be able to take advantage of that and adjust our QPF accordingly, and hence any type of snow amounts. So short and sweet, that's the end of my presentation, and I'll turn it over to Dan and Scott. You guys can direct any questions my way.
Thanks a lot, Dave. That was great to look at. I'm looking out at snow on the ground, so it's still winter up here north of 40 North. Does anyone have any questions for Dave? I don't see any in the chat. I will say that Mimic TPW is available in AWIPS. I have it in my AWIPS, so if you're interested in getting this via an LDM feed, contact me. I also know there's a advected layer PW product that Sierra puts out that lets you look at different layers of moisture and also total moisture within the atmosphere. That's also available via LDM. And there's a GOES derived product, TPW. So there are lots of ways to look at total precipitable water. I would say find the one that resonates with you and use it. And having said that, I'll ask if there are any questions. I know it's an interesting weather day. Well, the lack of questions makes me think that Dave did a great job with his presentation showing how you can use this product at different times to help with your snowfall estimates. So I want to thank Dave again for giving this presentation. If you have people in your office who you think should view this, this was recorded. So we will have that recording available later today. And I'm going to thank Dave again, and we'll give you an extra 7 or 8 minutes back on your day to look at the weather. Thanks.